Welcome to Mbose Educator. Mathematics Class 10, New Book, Chapter 1, Exercise 1.1, Question number 3 and 4. This is Exercise 1.1. In this exercise, altogether 7 problems are there, out of which we have already solved question number 1 and 2. In this video, today we shall solve question number 3 and 4. For that, let's go to the another page. This is question number 3. In question number 3, it is said, find the LCM and HCF of the following integers by applying the prime factorization method. In this number, there are 3 parts are there, number 1, 2 and 3. Here some integers are given. We have to find LCM and HCF of these integers using a special method called prime factorization method. Let's take number 1. Here I have written, already I have solved to save the time. Number 1, 12, 15 and 21. So separately we have to find the prime factors of 12, 15 and 21, which I have already done here. So first 12, this 12 I have taken here. 12 we can divide by 2. Result will be 6. 6 again we can divide by 2. Result will be 3. And 3 itself is a prime number. So we can divide it by 3 itself. When 3 is divided by 3, result will come 1. We have to stop now. Similarly, now we have to find the prime factorization of 15. I have written 15 here. 15 we can divide by 3. 3 5s are 15 and 5 itself is a prime factors. So we can divide it by 5 itself. So 5 divided by 5, result will be 1. Similarly, the last integer is 21. So 21 we can divide by 3. 3 7s are 21 and 7 itself is a prime number. We can divide it by 7 only. When 7 is divided by 7, answer will be 1. So we have to stop after getting 1. Let's write as the product of their factors. So first 12, this 12. 12 is equal. All the prime factors of 12 here we have to write as the product. 2, this 2 into this 2 into this 3. As we know, the prime factorization we have to write in the power form or exponent form. So 2 is twice written here. Twice appeared, so we shall write 2 to the power 2. Similarly, 3 is appeared only once here, so we can write 3 to the power 1. Next, we have to write the prime factorization of 15. There are only 2 prime factorization of 15, 3 and 5. So we have written 15 is equal 3 into 5. We have to write as the power notation, that is 3 to the power 1, because 3 is only one time appeared here, into 5 to the power 1. Next 21. 21 has 2 prime factorization, that is 3 and 7. So we shall write 21 is equal 3 into 7. Is equal, we have to write, as we know, we have to write it in power notation. 3 to the power 1 into 7 to the power 1. Now we have to find LCM from this prime factorization. So I have written here LCM of 12, 15 and 21 is equal 3 to the power 1 into 2 to the power 2 into 5 to the power 1 into 7 to the power 1. How we have got this? Actually, you see, the list of prime factorization of 12 is 2 to the power 2 and 3 to the power 1. The prime factorization of 15 is 3 to the power 1 and 5 to the power 1. And prime factorization of 21 is equal 3 to the power 1 and 7 to the power 1. Now we have to check out which factor is common in all. That is 3. 3 to the power 1, 3 to the power 1, 3 to the power 1. And remember one thing, the common factors, out of these common prime factors, which is having the highest power, that one only we have to write. But unfortunately, all the common factors having same power, that is 1. 3 to the power 1, 3 to the power 1, 3 to the power 1. So 3 to the power 1 is common in all. That's why you shall write 3 to the power 1 first. Second, we have to check any other number is any other more number is common in all? No one. Only 3 is common. When we shall get there is no other number common here, we have to write all other left out factor together. That is, you can see 2 to the power 2 we have written here, 2 to the power 2. Next left out number is 5 to the power 1, 5 to the power 1. Then another is left out, that is 7 to the power 1, 7 to the power 1. Now we have to multiply all together. 3, 4 are 12, 12, 5 are 60, 60 into 7. 60 into 7, 6 7 is 42, 1 0 is here. So 420 is the LCM of 12, 15 and 21. Now we shall find out the HCF. So how to find out HCF? I have written here HCF is equal 12, 15 and 21 is equal to 3 to the power 1 equal 3. So how we got this 3? Actually HCF will be the common factor which is common in all. That one only will be the HCF. You can see here only one number, that is 3, is common in all. Other than 3, no one is common here. So only 3 is common. That one only will be the HCF. Alright, I have solved here question number 1 of number 3. Let's solve question number 2, 17, 23 and 29. This is question number 2, 17, 23 and 29. Let's find prime factorization of these integers. As we know 17 is a prime number and we can divide it only by 17. 17 is divided by 17, result will be 1. Similarly, next integer is 23. 23 also is a prime number, so we shall write 23 here, and the prime factorization of 23 will be only 23 because 23 is a prime number. So we can divide it by 23, answer will be 1. Similarly, 29 is also a prime number, so we can divide it by 29, answer will be 1. So we shall write this. As we know, 1 is not a prime factor, but when there is a prime numbers, we can write 1 also. There is some reason is there. Prime factorization of 17 is equal 1 into 17. We shall write in power form, that is 1 to the power 1 and 17 to the power 1. 23 is equal 1 into 23. You can see 23, 1 into 23 equal, in the power notation, 1 to the power 1, 23 to the power 1. Similarly, 29, this is the 29, prime factorization is 29 and 1. 29 is equal 1 into 29. So in the power notation, 1 to the power 1 and 29 to the power 1. Now we have to find the LCM of 17, 23 and 29. Here we can notice that there is no any common prime factors present in these integers 17, 23 and 29. So no one is common in all. So in this case, what to do? All the prime factors we have to multiply. From first integers, 27 is the prime factors into, from the second integers, 23 is the prime factors. From the third 29 is the prime factor. And we have to multiply all. 17 into 23 is 391 into 29 as it is written. 391 into 29, product is 11,339. So this is the LCM. Alright. Now we have to find out HCF. HCF of 17, 23 and 29 is, which number is common in all? As we know that is 1 only. As we know, 1 is not a prime factor. That's not matter during the HCF. And these numbers are called a special name co-prime. Co-prime are the numbers which has only common factor 1. The HCF will be only 1 because they don't have any common factor other than 1. And co-primes have the HCF 1 only. Remember it. So here we have solved the part number 2 of question number 3. Let's solve the last part of question number 3. Here I have written, in part number 3 it is given 8, 9 and 25. So first of all we have to find out the prime factorization of these integers. 8 we can divide by 2. 2 4 is 8. 4 again we can divide it by 2. 2 2 is 4. 2 is a prime number. We can divide it by 2 itself. Result will be 1. Similarly 9 we can divide by 3. 3 3 is 9. 3 is a prime number. We can divide it by 3. 3 divided by 3, result will be 1. 25. 25 we can divide by 5. 5 5 is 25. 5 itself is a prime number. We can divide it by 5 itself. 5 1s are 5. Result is 1. So let's write this prime factorization in the product form. 8 is equal 2 into 2 into 2 into 1. As we know, 1 is not a prime. Then also we are writing here as a factor. So we have to write in the power form now. 2 is 3 times here appeared. So 2 to the power 3 into 1 to the power 1. 9. 9 is equal this 3 into 3 into this 1 also we have written here. And in the power form 3 to the power 2 and 1 to the power 1. 25. The prime factorization of 25, only 2 prime factorization are there, 5 and 5. So 25 is equal 5 into 5 into 1 also I have written here. 5 is 5 appeared twice here, so 5 to the power 2 into 1 to the power 1. Now LCM. LCM of 8, 9 and 25. First see, any number is common here? No one. So all the prime numbers we have to write here. 2 to the power 3 into 3 to the power 3 into 5 to the power 5. Let's multiply 2 cube, means 2 to the power 3 is 8. 3 square is 9 and square of 5 is 25. Now 8 9 is 72 into 25. 72 multiplied by 25. Result will be, or product will be 1800. This is the LCM of 8, 9 and 25. Now we have to find out the HCF. You can see I have already written the HCF. 8, 9 and 25 is equal 1. How we got this? Already I have mentioned, which we have learned in the previous number, that is part number 2. The co-primes, the number which has no any common factors are called co-primes, which have only one common factor, that is 1, and that 1 will be the HCF. Alright. So here we have solved all the problems from question number 3. Now we have to solve question number 4. This is question number 4. In question number 4 it is said, given that HCF of 306 and 657 is equal 9, find LCM of 306 and 657. It means there are two numbers are there, 306 and 657. The HCF of these two numbers is 9. We have to find out the LCM of the same. Let's solve it. First of all, we have to write, already I have solved here, just we have to understand from here. Given, what's given here? HCF of two numbers. HCF of two numbers equal 9 is given. Product of two numbers, that we have to find out. Product of two numbers means which number is given, we have to find the product of this. Okay, 306 into 657. Now we have to find out LCM. Find LCM. So LCM equal question mark. There is a formula to find out the LCM. LCM is equal product of two numbers divided by HCF. Now see, in the place of product of two numbers, we shall write the product of two numbers, that is 306 into 657, and divided by HCF. In the place of HCF, we shall write the value of HCF, that is 9. So 9 is written here. Now by 9 we can cancel 306, we shall get 34. Now what to do? 34 we have to multiply with 657. 34 multiplied by 657, product will be 22,333. So this is the answer. This is one of the important questions. Remember it. So with this we have completed all the problems from question number 3 and 4. To get all the classes regularly, please subscribe my channel. We shall meet again in the next video. Till then, thank you very much.